Here we are given two functions, f of x equal to a power cos x, g of x equal to sin x power a. A is a natural number. A belongs to n. Then what can we say about the relation between these two functions? F of x is greater than g of x for all x. F of x is less than g of x. F of x equal to gx for infinitely many values of x. Or f of x is never equal to g of x. So if you see these three options, right? F of x greater than gx, less than gx, or equal to gx. Obviously, if this is equal to gx, then these two are wrong, right? If f of x equal to gx for at least one value of x, then that means a and b are together wrong because it is given all values of x, f of x is greater than gx, or all values of x, f of x is greater than or less than g of x. Okay, in fact, d also will become wrong. Okay, so it is saying D is saying is never equal to g of x. But if you are able to prove f of x equal to g of x even for one value of x, then that means this is wrong, this also is wrong. We can't still say whether it is true for multiple values or infinitely many values of x. Let us try taking this. Okay, a power cos x and sin x power a. Okay. So, if we take x as pi by 2, x as pi by 2, what is cos pi by 2? Cos pi by 2 is cos 0. A power 0, this is a power 0. And what is sin pi by 2? Sin pi by 2 is 1. This is 1 power a. And a is a natural number. 1 power anything is 1. A power 0 is 1. Right. So, when x equal to pi by 2, this f of x is equal to g of x. What that means? That means this is wrong. This is also wrong because here it is given this should be always greater than this. Here it is given this should be always less than this. But we have figured out that for x equal to pi by 2, these two are equal. Right. What does that mean? And cos x and sin x are periodic functions. What does that mean? For every pi by 2 plus another 2 pi. 2 pi, 4 pi, 6 pi, whatever, 4 pi, 6 pi, whatever, you will still have cos x as 0, sin x as 1, right? Because these two are periodic functions. So then we will still get the same result, a power 0, 1 power a. So there are actually infinitely many values of x. What are those? All pi by 2 plus multiples of 2 pi's, right? For all of those cases, these two are equal. Another case also, we still want to uh, give us more confidence. Let's say if we take something like a as 2 or a as 3, let's say 3 power cos x, and this one becomes sin x power 3. Okay, sin x power 3. So what is the range of this? This is minus 1 to 1, minus 1 to 1 whole power 3. So it will be minus 1 to 1 again. Minus 1 cube is minus 1, 1 cube is 1. Okay, so what about this one? 3 power again minus 1 to 1. What does that mean? 1 by 3 to 1. Okay, so this can be negative, this can't be negative. Right, this is one way of seeing that this is not always greater than this. Right, this is just convincing ourselves in other ways. So what does that mean? G of x and f of x are equal at all pi by 2's and pi by 2 plus 2 pi's, 4 pi's, 6 pi's, and g of x is lesser than f of x, at least at some places. What that automatically means is because these two lines are meeting, these two graphs are meeting at pi by 2, let's say pi by 2 plus 2 pi, pi by 2 plus 4 pi, and all. Then obviously what that means is the other graph is crossing this graph. So, for example, if you look at the graphs, the blue one is sin x whole cube. This one, sin x whole cube, whole power 3. This one is 3 power cos x. 3 power cos x. So it is going to the maximum of 3 and minimum of 1 by 3. And this one, obviously, it is going to the maximum of 1. And these two are meeting at when it is pi by 2. That is this one, roughly 1.6. And then pi by 2 plus 2 pi. Right. That is again here. And here we can clearly see that one of the graphs is higher for some point and they are meeting at pi by 2's, And then obviously, because they are meeting here, there should be a crossing point. That means the other graph should be higher than the after the crossing point, the blue one is higher than the red one. And then again, when it crosses, again the red one would be higher. Right, guys? This is graphical way of looking at it. But simply, these two graphs, it is essential if, when we are able to show that these two are equal at least some point, then automatically means um, definitely one is not always higher than the other, right? And which automatically means um, the 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 point D is invalid, because here it is saying it is never equal. But we are able to show C. That means if we are able to prove C, A, B, and D are already disproved. Right, guys? Hope you like this. Thank you.